Hi there. I'm Phil Turek, currently a substitute teacher in physics and cheer at Cerritos High School. On March 5th, 2025, we held our annual Astronomy Night over at the Cerritos Public Library. At the end of the event, one of the members of the audience requested that I post the slides online. So here I am back in the classroom several days later, and I'm going to talk through the presentation that I gave that evening. It's been slightly tweaked up at the very end of it, but here we go. So over at Cerritos High School, been teaching astronomy a bit. And starting from the Earth and going out, we actually studied Earth science a bit and continental drift and the details about the Earth. But for Astronomy Night, I taught a bit about how the ancient Greeks were able to understand that the moon was shining by reflected light from the sun, and reasoning that the moon goes around the Earth at a constant speed in a circular orbit, and that the sun must be farther away from the Earth than the moon is. One Greek astronomer, I think his name was Aristarchus, measured how much time it takes for the moon to go from first quarter, where the sun is at a 90-degree angle to the moon, as viewed from Earth, to third quarter moon, where the sun is again at a 90-degree angle from the moon as observed from Earth, and then compare that time to going from third quarter to first quarter moon. And by doing geometry, deciding that the difference in time was about 1 day, he was able to estimate the relative distance from the Earth to the moon and the relative distance from the Earth to the sun. And he concluded that the sun was many times farther away from the Earth than the moon is. Other ancient Greek astronomers, or maybe even the same guy, was able to look at the size of the Earth's shadow during a lunar eclipse, and from that determine the relative sizes of the sun, the Earth, and the moon. And someone studying in the Library of Alexandria in Egypt read an account once about two guys digging a well in a town called Syene, I think, and they noted that when they ate their lunch on a certain day of the year, the sun was directly straight up overhead. And the fellow reading about this in the library said, aha, given that the Earth is a sphere, what if I surveyed the distance to a different town and on the same day of the year, the same time of day, measure the angle that the sun makes from the vertical, like put a stick in the ground and measure the angle of the shadow. He hired a group to survey it, and to the best of our knowledge, he determined the size of the Earth by this method very accurately. We just don't know for certain what unit of measure is the conversion to modern units, but we think it was very accurately done. So the ancient Greeks knew the relative sizes of this Earth, moon, and sun, and the relative distances. All this long centuries before the invention of the telescope. And even before the telescope was invented, other mathematicians and astronomers were able to work out the size of the solar system relative to the distance from the sun to the Earth. So they called that one astronomical unit. And for all the visible planets, all the known planets to the ancients, which means out to Saturn, they were able to calculate how far away those planets are from the sun in Earth-Sun units of distance. Okay, so we also studied a bit about the interior of the sun. There are spots on the surface of the sun, and we didn't know about that in Western culture until after the invention of the telescope in the early 1600s, 1610. The Chinese had been studying the sun much longer than that, without a telescope, true, but they would look at the sun when it was foggy, cloudy, sunrise, sunset, and during those brief moments of time when they could look at the sun directly, they noticed the sunspots and kept records of them. We now know that the number of sunspots that you see goes on a cycle of every 11 years, it goes through a peak. And this year is a peak year. So if you have an interest in making a pinhole viewer or using some other technique, you too could observe the sunspots that are taking place on the surface of our sun, currently fairly active. Thanks to our advancement of technology and science over the centuries, we've been able to figure out why the sun shines. And now we understand it's due to nuclear fusion taking place, that hydrogen is fusing together into helium, releasing vast amounts of energy, and that's going on in the core of our sun. So even though we've never stood on the sun, we've never burrowed into the core of the sun, we can put up a diagram like this one that shows what the internal structure of the sun is like. Now, one of the exercises we've had to do is to determine the scale of the solar system, or at least for the Earth and the moon and the sun. So I have a globe, and I'm going to pause this for a moment and then switch over to that. Stand by. Okay, so what I had done is bought myself a model of the Earth. Here it is. It's a beach ball size thing, and it shows a nice imagery of the Earth on it. You might be able to make out North America. Here's Australia. Super. So I'd ask the students typically, how large is the moon on this scale? And it turns out that the correct answer is it's about the size of Australia. It's smaller than the United States going across, but it's okay, so something like that. And then the next question is, so I actually have a 3D printed globe of the moon that someone made for me. Here it is. So then the next question was, how far away should it go from the Earth on the same scale? And students usually put it somewhere around here, maybe a little farther. So the answer is 12 meters away. And if you figured that a meter is just over 3 feet, we're talking about around 39 feet, roughly something like that, is the distance from the center of this model of the Earth to the center of the moon. All right, so that basically goes across this classroom that I'm presenting from right now. And over in the skyline room at the library, that was going across the skyline room pretty much during the night. Okay, so let's pause this for a moment. Okay, I have to admit this isn't going quite as well as I thought it would, but back during Astronomy Night, I held up a globe of the Earth and I asked to scale how large would the sun be on the scale. Now, the sun is nearly 1 million miles in diameter. And so the short answer is to scale, it would be larger than the room that we were in, the skyline room in the library. As you look at this Google image of the library, you can see a yellow circle outlined. That represents the size of the sun on the same scale where the Earth is a beach ball. So next question was, how far is it to get to the orbit of, well, I guess the question first was, what are the 4 planets nearest to the sun in order from the sun out? Okay, so Mercury, Venus, Earth, then Mars. On this scale, how far would you have to go to get to the orbit of Mercury? And here's the answer. It is over 1 mile away. Every square in the city of Cerritos is a half mile. Every major street is a mile. So from Bloomfield to Norwalk is 1 mile. Oops. Yeah. Did I say that right? From Shoemaker to Norwalk is 1 mile. Okay. You get the idea. So that's Mercury. And then to do Venus, Earth, and Mars, you'd have to zoom out even further and see that you have to go miles to get to the orbit of the Earth, the blue circle. Once you go past Mars, it's a huge step up to get to the next planet, which is Jupiter, and then uh, you know up from there. So then the question became, well, what if I shrank the sun down so that it wasn't the size of the the Cerritos Library, but shrink the sun down to the size of a tennis ball? So the scale is much, much smaller now. And on this new scale, how far would you have to go to get to the nearest star to our own sun? The nearest star is called Proxima Centauri. It's 4.246 light years away from the Earth. A light year is the distance that a beam of light would travel in the vacuum of space over a time span of 1 year. Light travels at 3 times 10 to the eighth meters per second. And so over 4 years at that speed, shrunk down to a scale where the sun is the size of this tennis ball, means we would have to travel to Fort Worth, Texas, to get to the nearest star the size of a beach ball on the scale where our sun is the size of a beach ball. So space is incredibly vast and empty. And that's just to get to the nearest star. To get to the size of our galaxy, we would have to shrink the scale again by quite a bit. Other slides presented during Astronomy Night here's just showing that our solar system has more than just planets in it. It has many asteroids. It has comets, other objects. The ancients, when they were studying the stars at night, they noticed that there were bright stars and there were dim stars. And they were able to make up a scale on a scale of 1 to 10. That was a little too hard. 1 to 5, they could do slightly better. So they made up a scale of 1 to 6, where number 1 stars were the brightest stars they could see. Number 6 stars were the faintest stars that they could just see. And this is, long before the development of city lights. So now we can say roughly how many stars do you see in that category of brightness? And it says, for example, magnitude 2 stars, you could see maybe 35 stars, magnitude 3, maybe 120 stars total over the course of a year. In Cerritos, we have light pollution, which means we can only see to maybe magnitude 3 stars. So here, you can't see very many stars. But thanks to technology, you'll see that you can use a device like your cell phone and get to see really at least as many stars as the ancients were able to see. With modern equipment, we've realized that the scale of brightness from the ancients can be measured with modern equipment, and therefore the scale can be extended. So the sun is magnitude negative 26, for example. And the fainter stars would be larger numbers on the magnitude scale. Luminosity is one of the characteristics we learned about the stars. So to your eye, they pretty much look like they're just white dots of light in the sky. That turns out to be because the human eye doesn't see colors in dim light, and stars are dim light. So to your eye, stars basically look like they're just white dots. If you use your cell phone or a camera or take an image, the equipment that we use doesn't have the same characteristic as your eye. And a photo that you take of the stars will show that there are actually many different colors. Scientists or astronomers who studied this stuff realized that there's 2 factors that go into how bright a star is, not just how far away it is, but the 2 main factors are how hot is it? So a cool star is one that's just glowing a dull red. A hot star is one that's glowing a bright bluish, whitish color. But then there's also the size of the star. Those 2 things together, called luminosity, is a determination of how bright a star is. So if you had a small, cool star, that's going to be very dim, very faint. If you have a huge hot star, that's going to be extraordinarily bright. But you can also, because star sizes are such a large range, you can have a large, cool star that is bright and a hot, small star that is dim just because it's so small. When you plot these things on a scale, there's a trend that shows up, and that's this diagram on the lower right. Most stars spend most of their lives along that diagonal line called the main sequence. Here's just another representation of it. And what we've learned is that the cool, small, dim, reddish stars sip their nuclear fuel very slowly. They can live for trillions of years on the main sequence. At the other upper left region, those are very massive stars. They're very hot. They're gulping down their nuclear fuel so fast that they're only going to live for a few million years as opposed to trillions of years for the small stars. Here's a complicated diagram showing how they all begin as a cold cloud of gas and dust in space, and then they take different routes over the course of their lives, basically all determined by how much mass they start off with. Here's the same chart, kind of straightened out a little bit. Our sun goes on the upper route, and it will eventually become a white dwarf. Right now, it's shining as a main sequence star, and it will for billions of years more. The higher the mass of the star, the lower route it's going to take. So there's a branch after it goes supernova. It could become a neutron star, or if it has a lot of mass to start off with, it could even end up as a black hole. This background image of a T-Tauri star is just some of the new information that we're learning these days. It's showing a star that is just starting to shine and turn on. Little reminder that there's a path that takes, for example, our sun on the right branch here. After it becomes a red giant, it can kind of burp off its outer layer. And in a telescope in the old days, that would look like a planet instead of a point of light, which is a star. So stars look like little dots even in the largest telescope, whereas a planetary nebula has a distinct size to it that, that's how they got their name. Oh, it looks like a planet, but it's really sort of a cloudy thing. So here's just a beautiful picture of one as an example. This Helix Nebula has the nickname the Eye of God. It's not really an eyeball looking at you. It's actually a sphere like a soap bubble. But as you look through the thin part of it, you barely notice that you're looking through it. And the edges of it are much more pronounced. So it's just one of many beautiful things. And the different colors, yes, they're giving us information about what is the composition of this structure. Black holes are ever popular and of interest to my students, so they wanted to have some slides about that. And, fun fact, as you fall into it, you're speeding up. As you speed up, there's so much friction, you start glowing in X-rays. And as you speed up faster and faster, time slows down. So ironically, you end up falling into a black hole until the end of time. Pretty crazy and wild. Here's a diagram showing the structure more of what a black hole has to it that we can understand. And even though it's black, we can see where it is by the food that it is swallowing. So if it's swallowing up a star, then it's going to be glowing in X-rays as it is falling into the black hole, and we can make out where it is. just another structure showing what we know about them. And the most massive black hole that we know of, the little fine print says that's 40 billion times more massive than our own sun. Impressive. With modern equipment, we're able to identify more details about our universe. And of course, the question always is, how did the universe begin? Does it go on forever? Is it infinitely old? We now know that by different lines of evidence that the universe appears to be 13.8 billion years old. The diagram, the colored image on the upper right, is a map of the entire universe in the microwave region. And what it's showing is that it's not all uniform, smooth, one color. There's clumps and there's voids. And those are details about the early ages of the universe that in turn lead to the theories explaining why the universe looks to us the way it looks today. One popular question is, there's a galaxy coming towards us, the Andromeda galaxy. What will it look like in the future when it collides with our own galaxy? So we have developed the technology to look into the past to understand how our universe grew to be the way it is today. We can also do computer simulations and project into the future. What do we think it will look like years from now? And this sequence of images follows along with a computer model that says when the Andromeda galaxy, which is hundreds of billions of stars, collides with our own Milky Way galaxy, which is also hundreds of billions of stars, most students think, oh, the stars are going to hit each other. But if you think back to how much space there is from one star to the next, physically, the stars are not really going to hit each other except for maybe two or three out of the whole bunch. But gravitationally, they're going to interact with each other. And it's going to go through contortions and distortions. And eventually, what will happen is that the two galaxies will end up merging into one even larger galaxy. Other types of new technology. So when I was the age of my students, the only planets we knew about in the entire universe were all the planets of our own solar system. Using the Doppler effect and at least three other independent forms of technology, we now know about thousands of planets around other stars. And we're discovering quite a significant number of them could be Earth-like planets. They're in the Goldilocks zone where they're not too hot, they're not too close to a star, they're not too far from a star. They're in that little region where there could be liquid water. We think that's a necessary ingredient for life as we know it. And so the question is, are there aliens out there? I can't tell you, although there's interesting new articles that suggest that the government knows more than they're telling us. What I can tell you is that our studies about how many planets are out there around different types of stars and how many are Earth-like, we can now tell you that when you look up in the sky at night, about one out of every five stars that are sort of like our sun that you see in the sky can have Earth-like planets around it. And so that means there are billions of planets in our galaxy that are capable of sustaining life as we understand it, theoretically. Okay, so another interesting topic recently was we now understand that asteroids have had a major impact on the development of life on Earth, that the dinosaurs, for example, their extinction was caused by a large asteroid impact off the Yucatan Peninsula. The map of the Earth down below is the risk corridor for a recent asteroid where it was predicted that it might strike the Earth in December of 2032. As you look at that risk corridor, So anywhere along that red line is where it might hit. And even though it's the size of maybe a football field, the destruction would be enough to destroy an entire city just because of physics, so much kinetic energy. About once a year, there's a conference of people who are trying to discuss how do you detect asteroids that are threatening the Earth? And then if you do find one, what are you going to do about it? And that second part is the hard part. So we don't really have very much technology available yet to do something about an asteroid that is approaching us. But it's the politics involved as well. So look at this threat corridor. It goes over Africa, it goes over South America a bit, it goes over India, it goes over Asia. And so if this scientists and engineers say, okay, we think we can push the asteroid enough so that it will miss the Earth completely. But to do that, uh, its predicted impact is going to have to change for being over middle of Africa to being over the middle of India or maybe over China, and then finally it goes off the Earth. And there's only, let's say, a 60% chance that we're going to be successful. Imagine the concern of the part of the world that includes India and Asia about an engineering project that has that risk with it. So getting the world to agree to a plan and cooperate and actively do it is still the biggest hurdle to preventing a dinosaur extinction level event. Three. Okay, I've had to take a break. It's actually not the same day anymore, but I want to continue my Astronomy Night slideshow. I've taken the liberty of inserting a few additional slides to help with this last portion of my Astronomy Night presentation. So what's up on the screen right now is a picture that I took of a comet from my home in Huntington Beach this past November, and so November 2024. And the point of this is just that you could start off with astronomy with just your cell phone and participating in current events. For example, this date of recording is now Thursday, March 13th, 2025, or 14th. It's the 13th. So tonight, just before midnight local time, will be the midpoint of a total lunar eclipse that's taking place. And so that's an event that you could go outside and just look up in the sky, assuming the storms finish and the sky clears up by tonight, and enjoy it yourself. If you have a camera, you could put it on a tripod and take a photograph, a picture of the lunar eclipse. And there's many creative ways you could do it. You could take a sequence of pictures showing its phase over time. You could take a picture just at the midpoint of the eclipse. Here's a photograph image I took of a comet, and you can make it out. All right, so this last section of my Astronomy Night presentation has to deal with my own Mars project that something I came up with and have been chipping away at for a long time now. So my students suggested that I start off by presenting my credentials. And I thought about that and I asked myself, so does that mean like which colleges I attended and which degrees I have? Does it mean where I worked? And for this last phase, I decided my most important credential is, what's my motivation behind this? So here's the story. Just before my birthday, which is now decades ago, just before my birthday, there was a blizzard that hit the area where my family lived, the farm that my family owned. And on the day of my birthday, my father called up the local government and asked them to come and plow the road open that we live on so that he could drive my mom to the hospital so that I could be born in a hospital. And they said no. uh, but they did say if he could make it half a mile to the state highway, then they would plow open the road the remaining 18 miles to the hospital so that I could be born in a hospital. And it turns out that my father, I guess, was born on our kitchen table, and his father was born on the same kitchen table years past. But my siblings were not, so my dad was just determined. So he made up his mind and he took a shovel. He went outside and he started tackling these snowdrifts that were 9 feet high, blocking our road. The neighbors got word of it and they came along with their shovels. And eventually, someone came along with a tractor with a small plow on the front of it. So here's a photograph taken on my birthday. And it shows that the neighborhood came together, farmers, just to have the satisfaction of doing something helpful in the community. And yes, they opened the road. My dad drove my mom to the hospital, and I was born in a hospital late that same day. What I always thought about, thinking back on this story about my birthday, is how the neighbors must have felt good about themselves, a sense of accomplishment, that the community together on something that wasn't essential to do, but it felt good to get it done. And I've always wanted to come up with some sort of project that would repay the community in a way, in a larger scale, uh, have a project where the community comes together, works together on it, and has a good feeling of satisfaction at the end of the project. And towards that end, I've always thought of the planet Mars as being a tool that could be used for a community project. And my recommendation is if you've not read the book, you should read the book, The Martian, written by Andy Weir. The theme of that book is much like my birthday experience here, where a community pulls together, hoping for a favorable outcome at the end of the day, trying to help someone in need. Okay, so yes, there's the Brad Pitt movie that you could see, but I like the book version better. All right, so here's a little bit more of my credentials. More than 2 decades ago now, being the Mars activist that you could label me as, I was a member of crew number 8, living at a simulated Mars base near Hanksville, Utah. And so the structure of the habitat is behind me. These, our crew of 6 included NASA controller, geologist from Canada, planetary scientist from Finland, mechanical engineer, biologist, and me. And that's me in my spacesuit there on the right. And the way this simulation worked is a real mission to Mars takes 6 to 8 months to get there. And ideally, you wouldn't be there for just 2 weeks. You would be there for about 2 years while the planets line up again for the trip home. And then you come home back to Earth over a period of 6 to 8 months. The simulated Mars base has a crew of 6 rotate in, spend 2 weeks there, and then rotate out with the next crew coming in. So I was a member of crew 8. Crew 7 was mostly a group from France, although I did know one of the members of it from the US. And then crew 9 replaced us. And there was no carryover of the culture or sense of community from one group to the next one 2 weeks later. And this goes on over a field season, which is about as long as an academic school year. Today, if you were to look it up, they are up in the 200s at least, the number of crews that have cycled through just this one simulated Mars base. And it's been upgraded and expanded quite a bit from when I was there. They now have, you can look it up. But I look at Mars as a tool for change. I surveyed the students that I'm currently teaching. I'm currently back in high school for just another month, and then I'm going to rewire myself. And I asked them, "What's broken with the world today?" And here's the main items from their list. Top of the list, corrupt politics, and then below that, violence. Nuclear weapons was a concern to a significant number of these students, and racism, double standards, not treating humans equally. There's the written statements about it. And I also asked them, what could you do about it? And they put forward a number of reasonable, well thought out proposals and suggestions. And a good chunk of them were things that we should be doing already. They're on the books that says, yes, we treat people this way. We're just not really enforcing it ourselves, disciplining ourselves to follow our own ideals. So this is something new that wasn't on Astronomy Night. So let me try to talk you through it. This blank grid here is my way of representing maturity of people over time. So at the bottom of the graph is how you start off as a child. And you start off, I'll call it below the law, where at first you just are getting used to being alive and you're not really aware of the difference between hurting other people and helping other people. You're in your own little world, and it could be a make-believe world, and you're a toddler and you imagine yourself as, astronaut or pilot or king or knight in shining armor, whatever it is. That's you're below the law. And so as you go up this graph, we're going through levels of maturity. So the next level up is called the age of reason. For most people, this is between the ages of 7 to 9. You become aware of the distinction between, I'll call it good and evil, but right and wrong. That you're part of a civilization that you live in. And then, for most of us, we spend our lives living within the law. And off on the side there, I got this little moral compass that indicates you're following your moral compass, but you're following the rules of the road, so to speak. And then for the people who are really mature and think about this, those are the people who are involved with creating the laws and editing the laws that we're following. So I tossed in a slide to kind of visualize this a little bit. For those of us who live within the wall, we have our moral compass, but we have the rules of the road to follow, and we're trying to go in the direction towards, at least in the United States, liberty and justice for all. And the roads might not take us directly there, but they're not something you want to disregard. So the act of getting into your car and stopping at the stop signs and obeying the traffic laws is your way of visually affirming to the people surrounding you that you are living within our laws. Sometimes the laws are not taking us where they should. And that's the really mature members of our society to kind of take it upon themselves or are tasked with creating our laws or editing our laws or sunsetting our laws if they're obsolete. And so it's more like there's not a road yet to the destination that we want to get to, liberty and justice for all. You have to rely much more on your moral compass to guide you. And examples of people who've done this, I would suggest that Muhammad Gandhi was such a person, and Nelson Mandela and Rosa Parks. These were people who were addressing laws that weren't going the right direction or weren't going or were going in the wrong direction. And through their efforts, sometimes that's labeled what? Peaceful, civil disobedience in some cases, but really just advocating to do what's right morally. Okay. So it's a tough it's a tough job to do. Most of us don't do that. I don't know if I could do something like that. I'm pretty comfortable living within the wall for the law for the most part. Okay, but my big idea is to try to bring together a group of people to, well, like it says here, agree on things. And that's what's going to be remembered over historical times and use Mars as a tool for enacting this social change. Mm. So here's a chart I got from an organization that's working to make the United States more united. And they've laid out, this is down to a resolution of the county level, that the United States is really a combination of multiple subcultures. They each have their own history. For example, it says here the Tidewater uh, group in Virginia. That represents the offspring of nobility originally in Europe, where they had their manners, they had their all the people who lived and worked for them. When they came to the New World and settled in Virginia area, Chesapeake Bay area, there were no developed roads. So it really became developed through the waterways, and that led to plantations and developing tobacco as the main product. So they really had their own isolated town that they ran and managed. And yes, they brought in slavery to help make this happen. They had to be uh, businessmen enough to know that they had to buy more land farther west because the tobacco would exhaust the soil in just a few years. And so you had to expand west or else go out of business. Many of the original founding fathers and original leaders of the United States came from the Tidewater region because they had the most experience of running a business, a community. And then each one of these, like 11 major groups, has their own history and background and culture. And right now, we're not really on the same page like we used to be. The page that we used to be on was the Declaration of Independence, and the Constitution is what unites us as being we the people. So, as a thought, and I don't know if my little insert here, if me on the screen is covering this up or not, but as a thought, here's some what I would classify as, positive traits about each one of these subgroups. They have their own culture, their own food. And just as a random example, here's a town or community from each one of these subgroups and what kind of cultural or artistic expression they have there. So you can pause this and study it. Here's a listing of some of their favorite foods from each one. Of course, since I'm from Yankeedom, I had to include Cornell chicken. If you haven't tried it, it's salty and vinegar, but man, for me culturally, that's a touchstone of what I identify with as one of the positive cuisines from my own little subculture. Okay, so the thought is I lived in a simulated Mars base for 2 weeks, and the culture never carried over. What I propose is that we have an expanded simulated Mars community. I think instead of just 6 people, it has to be at least 53 people. And a duration of 2 weeks isn't going to work. It needs to be extended over a field season and maybe have it build up where the first 2 weeks is just a crew of 6 that arrives. And then 2 weeks later, the second crew of 6 joins them and it builds up. Eventually, some people are going to want to rotate out. Some people will rotate in to replace them. So it becomes a steady state where it's maintained at 53 or so residents. And what we're trying to do there is germinate little Martian cultural values, maybe have them contemplate what a Martian government could look like. You can't build a real Martian government in an analog Mars base because you don't have the real conditions that you're facing. For example, uh, young families. Are you going to have teenagers help settle Mars, establish Mars? So it's not just trying to create a Martian nation, Martian society, but the main objective here is to use this as a tool for making changes back here on Earth. And that means we're really following along this little nascent, embryonic, germinated society, at first on an analog one on Earth, from which we can go through an iteration. So, first year, maybe high school students, teams of high school students are making the proposal about who they think should go into this analog Mars base for the field season. But basically, it's going to be adults that they identify. Maybe some high school teenagers are part of the crews that go in. It could be. And at the end of the field season, have it evaluated. So what you see on the screen right now is a report card evaluating the society, mostly government and society of the United States. This particular report card is several years old. It's not current events. It's put together by an organization called the Social Progress Index. You could try Googling that, or Social Progress Imperative. And they feel it's their job to score different governments around the world, as many as they can. And they've color coded the report card here. So blue means you're doing better than other nations, and red means you're doing worse than other nations or worse than average. As you look at this, your eye spots there's only one thing that we're above average at, and it says our quality weighted universities. So that explains why we see foreign governments send their best and their brightest to Yale and Princeton and, of course, Cornell. And after they get their advanced degrees, they go home. They return to their country of origin. We don't really have an attractive environment here for them to want to stay. And this report card kind of reflects that. So, what I would like to see happen is this annual competition of selecting what values and people go into an analog Mars community, run it through a field season, assess it at the end, like this, with some nonprofit group that does this for a living, and then learn from that. And next cycle, have maybe higher up the educational ladder people involved with this. So I propose starting with high school students because I like high school students and working with them. And I had experience working with teams doing international competitions, the International Space Settlement Design Competition. We did that for a while. The Mars Society has an international competition. And so it could be done. I kind of would like to work with the American Institute of Aeronautics and Astronautics because we need the technical foundation and expertise that goes along with this. Uh, Fold in perhaps what had been called the future farmers of America. Those are uh, a lot of high school students who are in the process of preparing themselves to manage agriculture with competence and the wisdom that we have accumulated over the years. Members of the Planetary Society, perhaps, Space Society, Mars Society. There are many organizations that could be drawn in to participate in this. It does call for staking out a location, setting up an expanded Mars base, running it. So, there's some logistics that goes with that. Is it going to be self-sufficient? Probably not. But can it simulate being a Mars settlement for a while? Probably yes. And there's a lot that we could learn from that. Now, we're trying to make a better version of ourselves as far as our government goes, as far as our civilization goes, something that goes in the direction of liberty and justice for all. And the students that I surveyed feel like we're not there yet. What if I told you that there, I suppose you could say, does exist, but I'll say did exist for sure, an advanced democratic civilization? And by advanced, I don't mean technology so much, but they were healthy in terms of their food supply and dealing with medicine as best they understood it. So I mean advanced in terms of democratic values and towards liberty and justice for all. So they did not have political corruption. You had no special perks for serving in government. You didn't get a special seat at the table. You didn't get a special house to live in. You didn't get, you know, any financial reward for serving in government. You had to earn the respect of your community, and they would vote you in. And as long as they respected your decisions, you stayed in office. And if you fell out of grace with them, if someone else had replaced you with the respect of the community, they were voted in and you were retired out. They didn't have violence like we are currently experiencing. They didn't have crime. They didn't have robbery. In fact, their citizens didn't even know how to lie because it just wasn't part of their civilization. And when they encountered a civilization where people routinely lied to them, wow, they took a real beating on that. It took them a while to even grasp what was happening to them. They had no standing army because they weren't at war with any neighboring nations. Obviously, I should say they had no nuclear weapons, so there was no threat of that. They didn't exist back at this time. They didn't have double standards. They tolerated multiple different religions. They had equal rights for men and women and serving in office and ownership of things. They had, in fact, here's a little story. A delegation from this nation once visited London. And while they were there, they saw a bunch of just homeless people, a family, lying on the street. And people walked by them without a care, ignoring them. Oh, homeless people. And they asked them, and the delegation asked their guides, what's going on here? And the guides explained, oh, those are refugees from the war going on in Germany. And the delegation had never seen anything like this before of treating human beings so callously, so indecently. And on the spot, they offered them land back in their home nation and said, look, you can come, bring your family, and settle in our nation, and you'll be better off. Okay, so that's the kind of people these were. And who was this nation? Who were these people? Okay, well, the answer is uh, the five nations of the Iroquois. Uh, they were in the Finger Lakes region of upstate New York in the United States. And I feel there's two main factors that help them become such an advanced civilization in terms of democratic values. Sorry about that. I had to pause for a moment. Back to the story. Two factors that I feel that made the Iroquois, the five nations, so successful. And by the way, five or six. Let me explain that part. They didn't discriminate against immigrants. So a tribe came up from Ohio, and the Iroquois nation took them in. That's how they treated immigrants. So instead of being called the Five Nations of the Iroquois, they're now called the Six Nations of the Iroquois. What I feel are two main factors is their architecture. Instead of having individual teepees or individual homes, they had a community shelter that was uh, arranged by family, then clan, then tribe. And that helped the community be an integrated, cohesive, united community. And the second main factor, I feel, is that they did not have private property ownership. Colonial America and now the United States is very big on private property ownership. And we keep associating money with power. If you're wealthy, then you're powerful. If you own a lot of land, then you're powerful. Whereas the Six Nations of the Iroquois didn't have that philosophy or mindset or cultural experience. For them, if you were the best speaker with the best vision and moral compass to guide the community towards a better life, then you were the most powerful member of the community in that sense. But you were always the representative of the will of the community. And they weren't confused by land ownership and equating that with power because they didn't have private land ownership. So Mars right now is a clean slate, and it certainly has a severe labor shortage. So there's a need for immigration to Mars. One of the proposed first purposes of a settlement on Mars is to serve as an inventor's haven to allow the creativity of new ideas to flourish and to try them out on Mars. I would add to that that Mars could be a place for, uh, I'll say, brainstorming, how to address climate issues that are facing our own planet back here on Earth. And how do you enable the expansion and survival, not just survival, but the thriving of different endangered species that are here on Earth? I mean, at some point, it might make sense to set up a little biome on Mars as part of a effort to restore a better life for everyone here on Earth. Okay, so pretty wild thoughts out there, and I really only have one slide left. So this is the power of AI or the weakness of AI, if you like. So I asked Chat to generate an image that would show the architecture of an Iroquois longhouse coupled with Martian settlers. And it ended up creating three different images. And here they are. This is kind of humorous to see people in spacesuits walking around wooden structures. But the concept of the Martian settlers looking deeply into the best examples that we know of democracy functioning here on Earth and incorporating the insight and the understanding that comes with that into the Martian settlements is the intent of these computer AI generated images here. Okay, I hope you've enjoyed this PowerPoint presentation from Astronomy Night. I do want to kind of close out with, for my own project, when I talk about setting up a Martian civilization, it's not my vision that the intent here is to go and create a community on Mars that goes separate from us and does their own thing. The whole intent of this particular project of mine is for it to act like a feedback loop to our own civilization here. And for that reason, it's not necessary to wait 30 years or however long it might take before a community is established on Mars. That's why this analog Martian settlement could be so useful right now in current events. That if we make the effort thinking about how to create a better version of ourselves and germinate that in this little simulated analog Martian settlement and observe it and learn from it and then have the experience of that, perhaps some of the participants will become social influencers. Perhaps some of the participants will actually go on and work in public service and become leaders. Some of the people who are involved with creating and editing our own laws back here on Earth, particularly in the United States. That for me is the tremendous value in doing this analog Martian settlement, not wait until people go to Mars. The research has shown that whatever the founding cultural values are in a newly developed area, that becomes the dominant culture for hundreds of years into the future. So it's tremendously worthwhile for us to think about what would a better version of ourselves be like if it were emplaced on Mars. What do we aspire to be the best values of a Martian society? And then try to germinate those values in a little analog community here on Earth and see that it could be real and try to incorporate it already. That's my food for thought, my author's message. I hope you have enjoyed this presentation from Astronomy Night. I've embellished the end of it a little bit for those of you who were there on March 5th. Regardless, I hope you find the whole idea of learning about our place in the universe uh, interesting enough to want to go out on your own and maybe get an app that lets you hold your phone up to the sky and identify what star that is or what planet that is that you're looking at. Maybe go online and see astronomy picture of the day. Maybe get involved with my Mars project here and trying to find a way to help make it happen in our lifetimes. Regardless, it's been a pleasure trying to share my ideas and thoughts with you and the thoughts of the students who put together these presentations. And have a great night. Goodbye.